Okay, so this question is about measuring reaction time, and it's an experiment that you might have done before. So you drop a meter ruler, and the person whose reaction time is being measured tries to catch it as quickly as possible, not knowing when it's dropped. Okay, so they've done this experiment 4 times, and here are the results. And the first question is, what is the best estimate of the true value of her reaction time? Put a ring around the correct answer. Well, best estimate is usually to take an average. So what you should do is add the 4 trials up and divide by 4, because that's the number of repeats. So you always add them all up, divide by the number of repeats. The only thing to watch out for is outliers, which you might want to take out, but you would normally have a reason to take them out. There's not really any outliers here, they're all pretty close together. And if you do that, you get 0.2. Okay. Now, you should always have a calculator to do this, but here you don't really need one, because you can see that if you put the sort of trials in order, they go 0.18, 0.19, 0.21, 0.22. So actually, it's kind of suggests it's 0.20, because that's the one in the middle, right? It's the mean is going to be in the middle of all the readings. That won't always work exactly, but here it gives you a clue. If you didn't have a calculator for any reason, you could sort of work it out that way. But the best thing to do is to actually calculate it. Add them all up, divide by the number of readings. And then what is the range of the results? Well, this is something you would have done in Year 10 when you did data analysis, and also in your investigation this year. It's just the smallest to the largest number. So just be really careful, right, that you get the right answer. So here the smallest is 0.18 and the largest is 0.22. So the range is 0.18 to 0.22. Okay, moving on to part B. So we're now comparing the reaction time now that she's drunk an energy drink. Okay, so she did the experiment once, and then Ellie drinks an energy drink. Half an hour later, they measured the reaction time again. 3 trials this time. Here are the results. What can you conclude about the effects of the energy drink? Justify your answer. Use your answers to part A to help you. So they've actually specifically directed you back to look at your answers to part A. So what is the best estimate and what is the range? So you need to make sure you talk about those in your answer here, otherwise you're not going to get all the marks. Okay? So the first thing you should do is to calculate a new mean for these results. And when you do that, you add the 3 up, divide by 3, your mean is 0.16. Okay? You should then note that that is less than the previous mean of 0.2, which kind of suggests that her reaction time has sped up. It is also outside the previous range. Okay, so if you look at the range 0.18 to 0.22, 0.16, the new mean for her reaction time after the energy drink, is outside that range, which is another suggestion that, yes, the reaction time has improved. And it also, all reaction times are less than the previous one, so all the results in this table are less than every single result in that table. And the ranges do not overlap. And if you remember talking about real difference, right, if there's a real difference between 2 different sets of data, then the ranges will not overlap. And here that is the case. The top time here is 0.17. The bottom time here is 0.18. So they don't overlap at all. Okay? So those are the points you need to make in order to get the marks here. Okay? And really, you can only really conclude that her reaction time decreases or she gets faster. Okay, there's any sensible conclusion because all the data points towards it. And then the final part of the question, the ruler speeds up as it falls. Why does the ruler speed up? Put a tick in the box next to the correct explanation. Well, falling objects always are losing gravitational potential energy because they're dropping in height. Remember, we can't create or destroy energy, so we have to transfer it into something else, and that something else is kinetic energy. So as the gravitational potential energy decreases, the kinetic energy of the object increases. That means it's speeding up. If you get a question like this with tick boxes, remember always to try and get rid of ones that make no sense at all. If you remember that kinetic energy means movement energy, then the second one makes no sense because it says, why does the ruler speed up? The kinetic energy remains constant. Well, that's rubbish. Can't be that one. Okay, so you can get rid of that one. Even if you're guessing, always get rid of the ones that are really ridiculous and clearly not right. Okay, And also, if you know anything about gravitational potential energy, this bottom one is rubbish. So really it's a choice between these two about which way around the energy is transferring. And if you just remember what the energy types are, then it has to be this top one. If it's speeding up, it has to gain kinetic energy. Okay.